Hi, welcome to our pre-calculus. Today's topic is verifying a trigonometric identity problem type 2. Very similar to the previous set of identities we had. Now we give some role to reciprocal and ratio identities. So here is asking us to prove that cosine square of x times 1 plus tangent square of x is equal to 1. Again, I insist that you try to go through the steps of derivation by yourself and just use whatever is here as a hint in case you get stuck. So let's see what is it that we are supposed to do here. It says this is the left hand side of this identity. That's where we have started, and it says that is equal to cosine square times secant square. So the cosine is same as cosine here, and that expression is replaced by this one. Well, what rule is that? We learned by now that we are dealing with Pythagorean identities. In case you have any doubts, Pythagorean is these three, or rearrangement of these three. Like you can take some of these expressions to the other side. Here we have 1 plus tan square, which is exact copy of this. So that's being replaced by secant. So here we have to use, we are choosing Pythagorean for this step. That's what we have done. How about here? Instead of secant, we are writing 1 plus cosine square. So 1 plus cosine square, 1 over cosine square. What is that? That's of course reciprocal. Here. Secant is 1 over cosine. So what he does is to replace that with this one. In the last stage, cosine square and cosine square cancel each other out. And of course that is just plain algebra. It doesn't have anything to do with trigonometry. So over there we choose algebra for the last stage. Let's try another one. Prove that sine squared times 1 plus cotangent squared is equal to 1. This is almost identical to what we had a minute ago. Over there was cosine and tangent. Now it's sine and cotangent. So first of all, this equality 1 plus cotangent squared is being replaced by cosecant squared. That is, what is that one? That's of course the Pythagorean. From here to here, the step that's being taken is that cosecant is equal to 1 over sine, and that is the reciprocal. And this final simplification is simply algebra, and that takes care of this problem. So if you want to check it, then you want to go through all of these things and then check them, and well, this is just what we did. Okay, secant minus 1, secant squared minus 1 being replaced by tangent. Everybody comfortable with that? We have so our trig identity says that 1 plus tangent square of x is secant square of x. Therefore, tan square is same as secant square of x minus 1. So what I did is to bring the 1 to the other side. So that expression is same as tan squared is a statement of Pythagorean identity. Each of these identities can be written in so many different ways. So that's what has happened. Next, cotangent square, tan square. You can simplify that in a number of ways. So step one, let's go ahead and mark it that we apply the Pythagorean for here. Now again, remember you have many options for doing these identities. For example, you could have already applied the fact that cotangent and tangent are reciprocals of each other to get 1. Here it says, well, I want to replace cotangent squared by cosine over sine and tan by sine over cosine. What are these identities? So we are trying to give a name to the identity used in this step, even though probably we could have come up with something else. So if we say this one is due to quotient, and the last one is just algebra, so we choose algebra. Let's see if you're right. And so on. So the identities in this section are pretty much similar to what we had last time. Once again, let me strongly recommend try to do the identity without using the help or hint that is provided below. Go through it by yourself and then come and see how does the software is going through the steps, and choose the appropriate terminology for each of these steps, and then you'll be all good to go. Okay, so until next time, good luck and God bless.